Okay, so we were talking about standard deviation, and we started talking about the normal model, z-scores, last week when we wrapped everything up. And we finished with the empirical rule and just kind of what that looks like, and flabbergasted. That's amazing. I don't know. I think we decided it's something in chemistry, but I don't know. I don't teach it in anything else other than this, but who knows. So just a quick little example of this. If we had the normal model for 30 and 5 being the mean and standard deviation, and this is going to be for fuel efficiency. In miles per gallon. Then we would draw our curve. So our mean is going to be 30. And then to do our standard deviation, we're just going to add this value to this 3 times and then subtract it. So 35, 40, and 45. In the other direction, 25, 20, and 15. And so then all we're going to do is just show the 68% is 1 standard deviation away, 95% is 2 standard deviations away, and then the 99.7 is the 3 away. And so from that, we could say something like approximately 95% of all cars will have gas mileage between 20 and 40 miles per gallon. All right. Finding normal percentiles. So when a z-score isn't exactly 1, 2, or 3 standard deviations, we have to use a z-table. So I think in your book it's page A74 for that. There is an option to also do it on a calculator. I don't remember right off the top of my head what the function is on the calculator that does that, but I'm sure I have it written somewhere in the examples when we get there tomorrow. The z-score or the z-table tells you the percentile value for any z-score. So basically how this tells you like 68% of the data is here, this allows you to say like, oh, 30% of the data lies here or whatever is essentially what that's going to tell you. So I'll show you right now on the Z table. So if you have your book, like I said, yours should be on page A74. Mine is on a different page for some reason. And I know there's a couple different versions of the book, so it could be that y'all's aren't on the same, but I think they're like close to it. A74, yeah. Yeah. It should look like this. Yeah. And what I do for like quiz, tests, whatever, is I will actually print out the Z table out of the book for that and give you one. No, I don't have one in here, but anyways. So we'll do the problem and then we'll come back to this table in just a second. So I'll put this to the side momentarily. All right, and this, like I said, this is just going to be a quick example. We'll do it on the calculator and stuff tomorrow. So, example, the normal model for SAT math tests is in 500, 100, so average of 500, standard deviation of 100. What percent of students score below 450? So I like to typically try to do a little, just a really small sketch off to the side of what I'm looking for, and that's more so going to be helpful when we get to doing it on your calculator, because, let's see, Joelle, you have the newer calculator, right? So yours is going to ask you a different set of questions than mine is going to ask. Yours actually makes it easier. So mine, you have to know what side of the little normal curve you're looking at, and you have to either do like 1 minus or just know like where it's reading. Yours is going to ask you left, right, or center, basically. If I'm remembering correctly the function, which I'm pretty sure is the right one in my head, but tomorrow I may completely say ignore everything I said today when I actually see it on the calculator again. But with your little curve, the middle is 500 and standard deviations are 100. So I'm just going to draw one standard deviation away. I want to know what percent of students score below 450. So I'm looking at this area over in here. So I'm looking at basically more or less halfway between the first standard deviation, okay, and then everything to the left of that. They won't always be as easy as, like, you could probably figure it out just by looking at this one. You might be able to, but anyways. So what we're going to do is we set up the Z. So this is the formula that we had. Y minus, so this is the value that you're given, minus your average over your standard deviation. So in this case, it is going to be 450 minus 500 over 100. And that's going to give you negative 0.5. So then you're going to take that number and you're going to go to your Z table, and it's going to ask you it's going to start out with your numbers here. So, oh, well, these are, oh, yeah. these are the negative ones. This is what we need right now, right? Yeah. So this is your first decimal place. Here is negative 0.5. Get this whole thing like in here. Okay. And then your second decimal place is what shows at the top. So we're looking at, it was just 0.5, so the second decimal is going to be a 0. So I come down that column, minus 0.5, so it's 0.305 or 85. 0.3085. That's the value. So 0.3085. And this is from the table. And so then this is what's going to give you your percentage. So approximately 30.85% of test takers score less than 450 on the test. So the z-score just tells you that you are basically half a standard deviation away, but we need to add up everything that is below that. And so while you might have been able to kind of figure it out, like in your head, in a sense, it's just easier if you have the table there to do it for you.
Where did the negative 0.5 come from?
So this was 450 minus, so that would have been, what, negative 50 over 100. So, yeah. And, like, this one's a little bit of an easier one. Like, the harder ones and stuff, like, your calculator will just give it to you, and it's easier. But I like to show you both ways because there's parts of the AP exam that you can have your calculator and parts of it that you can't. And so, like, they give you a z-table, so you also need to know how to read them. I'm not allowed to be with you the day of the exam. Like, I can, like, so the exam's at 12, so you take it in the modulars and, like, out back in, basically, like, I come out and I pray with the class before, and then I have to say bye, and I have to leave before the test packets get open. And I'm not allowed to know anything about the test until, like, after they release it on College Board. Now, last year, everybody, well, they were, like, talking about the problems. But I didn't, like, they would just tell me the type of problem. Like, but most of the problems I can see after. I can't see the multiple choice, but I can see the short answer ones after. So, yeah. But it's a long test. All right. Let's see. So if we did a modification to this problem, so I was saying, like, sometimes it's the left, sometimes it's the right, sometimes it's the center. So if the problem was changed to say what % of students score between 450 and 600 on the test. Then in this situation, when we look at our little curve, now we're looking at this area from 450 to 600. So we're looking at the center part of it. So we would still have to find the z of the 450 minus 500 over 100 and get that value from the table. So I'm just going to draw an arrow there so we don't actually need to write it again, which is just going to be the 30.85%. Then we also have to do it for 600. So we're going to replace the 450 with 600. So z equals 600 minus 500 over 100, which is just 1. So then you're going to go to your table need like another desk, I think. So this time we have 1.
It's not on here, so I'll make
There should be a positive one as well. It's over the next page over. So this time we're looking for the 1 column, or the 1 row. So 1's here, and then we need, it's just 0.00, right? Because it's just 1. So we need this. It's the 0.8413 is the one that we're looking for here. So this is 0.8413 or 84.13%. But I need the area that's between that, and so just keep the book. So these pictures are in the top corner of the table. If you look at them real quick, this is what I mean when I'm saying like the less than 600 one. So it's taking everything to the left of it, and then these ones. So yes, we're gonna have to subtract the bigger one minus the smaller one when we're doing it by hand. And like Ethan, when you're using like my calculator, you're gonna have to manually subtract them. Joelle, yours is gonna give you the option to choose center and put the information in, and it'll just do it automatically for you. So the newer calculators do that. I don't know why they don't, but so yeah, so the 0.8413, or you could do it as percentages, it does not matter, is going to give you that. So the conclusion then, like we drew above, is that approximately 53.28% of students score between 450 and 600 on the test. All right, so then, let's see. Percentiles to scores. So this one, we can also use the z-table to determine what they call cut scores. For specified percentiles, we find the corresponding percentile in the z-table, translate it to a z-score, then we use the z formula. Okay, so that's just a formula that we've been using, but we use it in reverse basically to find the cut score. So in the formula that we wrote, like with the variables that we wrote, you'd be finding y. So in like the previous example, like you'd be finding the value of 600. So again, the z formula is z equals y minus mu over sigma. So this would be something like the upper 10% of your class, or, you know, test scores or whatever. So if we did something similar to the SAT question, just to keep on that track, if you had something like what score marks the top 10% of the SAT test scores and so
He said he's gonna use the Z for
formula.
I said for
There we go. So with this one, to get a picture, okay, whoa, that's a bad curve. The top 10%, okay, is going to be up here. Okay, this is the 10% at the top for the Z value that we're finding. But what we need to know is that when we're doing this, the top 10% is the 90th percentile on the Z chart. So essentially what we're doing now, because we're doing this in the reverse, is that we're going to look on the Z table in the values that are in there, and we're trying to find the one that's closest to 90%. But we don't want anything that's below. We want it to be at least 90%. So when you look at this, where's my pencil? So when you look at this, what you want to do is you want to come down and you want to look at all these numbers. Now, if you look, they progressively get bigger going across. Then you come down and then they get bigger again. So left to right, going down, they're getting bigger. So we want to keep going until we get to something that's 0.90. So 0.9015, 0.9032. So we want this 0.9015. So now what we're going to do to get our Z value is we're going to say, okay, well, what row did it come out of? It came out of 1.2 and then come up 0.09. And so that is going to be 1.29. And the value that gave us that was 0.9015. Okay, and I would always write both because, like, if you had told me the 1.3 on, like, a test or something, then I would at least know where you got that number from because I would see where you, like, what number you started with to have gotten that. So always make sure you write both. So now this is Z. Okay, so into the formula, we're plugging in everything that we had. We're using the same mean and standard deviation from the previous example. So we would have 1.29 is equal to y minus 500 over 100. And then we just need to solve for y. So that's going to be 129 is equal to y minus 500. So if we add that, we're going to get 629 equals y. And so then the conclusion is that scores in the top 10% are 629 or higher. Okay. I actually do have the notes about the calculator, so I'll go ahead and give you those now, and then that way you'll at least have them when we get ready to do the stuff tomorrow. So there's 2 different calculator functions that we use in this particular chapter. And I will tell you that a lot of the functions are going to sound similar as we go throughout the year, so just be prepared for that. But for these, if you're using your calculator, the function normal CDF will solve for percentiles. So like the first examples that we did. And the menu is going to read something like what I'm about to write. It'll say something like lower, and so it wants you to input the lower boundary, Z, or the value that is given. It'll say upper, which is the upper boundary, which again is Z or the value. And so like the ones where we wanted anything below, what was it, 450? I don't know, we're just gonna make something up. The problem that I wanted anything below 450, basically you would be putting in a lower value of something that's like a really big small number basically, which I know that sounds like counterproductive, but like I would use like 0. So 0 to the upper is going to be 450 in that case. And then you're going to put in what the mean and the standard deviation is. So then the menu is going to show you a little mu, which is your mean value. And then it's going to show you a sigma for your standard deviation. And so then just the thing that I was commenting, if you have one value, okay, and that's all that you were given, use a very high or low, as the case may be, number for the other boundary. So commonly what you're going to see on there is you'll probably actually see 1E99, so 1 times 10 to the 99, or negative 1 times 10 to the 99 is something else that you might see as like your lower, and then your upper would be like, if you're only given 1, those would be the 2 values that you would be using around that. But that's going to give you the percentile, okay, that we were looking for in the first example. If you're given, or if you want the cutoff value, yes.
Is that an I or a 1?
1. Right here?
Yeah.
Yeah, it's a 1. I'll put the little tails on it so it's easy to tell. So then the other one, I'll do this one in purple, is INV norm. So INV norm is the other one. And this will give cut values. Or z-scores. And so it's going to ask you for area, which is going to be the percentile. Mu, which is going to be the mean. And sigma, which is going to be the standard deviation. Also, I'm starting to think this isn't the section where it's going to be different, but it is coming up, the section where yours is going to be different if it's not this one. Once I actually pull up the calculator functions tomorrow, I'll be able to tell you for sure. But if you're using z-scores, or well, here, let me do this in a different color. If you use z-scores, use n for 0 and 1, so have the mean be 0 and standard deviation be 1. But if you use actual data, okay, and it depends on what the problem gives you. Some of the problems are going to give you actual data and some are not, and if they don't, then you're going to use z-scores. Then the mean and standard deviation of the data will be mu and sigma, and they may still write it as that when they give it to you. And then just another little note thing here. Don't round until the end of a problem. This is the last thing. Let your calculator keep the precision. Okay, and we'll talk about how to store things if there's something that needed to be stored or whatever as well. But we always want to make sure that we keep it all the way till the end, so.